Today we're going to talk about TMC's RP137. What RP137 is the ability to test the 7-way to make sure we're maintaining proper voltage at the nose of a trailer. And we're talking about 3 circuits really. We have our common ground, which everything on the 7-way uses, and the primary thing we're talking about today is being able to power the ABS circuit. On this one we actually have a backup on the stop lamp circuit. If we do not have power on the aux or ABS, it does have a redundancy circuit built in through the stop lamp circuit. The key whenever you're doing the test for RP137 is the circuits have to be placed under load. If you don't use a load, you can't have voltage drop. RP137B shows using headlights to be our load so we can do a voltage drop test on the cable. We've just made an easy fixture here, just like anyone could make in the field. We're using 2 headlights, one that we have connected to the aux pin and one we have connected to the stop lamp circuit. That way we can easily plug in our 7-way cable, turn each circuit on. We've got a voltmeter so we can look at what the voltage is back here at the end of the circuit. And we have a clip-on amp meter so we can verify what our load is. We need to make sure exactly how much current is flowing so we can look at that chart in RP137 and verify it does meet spec. The chart in RP137 goes back to a comparison between the voltage and current, that the resistance stays constant. So if we have a 5 amp load, you're going to have a certain amount of voltage drop. If you double that to a 10 amp, you're going to have twice as much voltage drop. You're simply going to look at what the load is, which is your bottom. Then you look at the side here and says, if I have a 10 amp load with the truck running as per the spec, I should see at least 12.5 volts at the nose. If I have a 20 amp load, I go up my line here, it says I'd only have to maintain 11.5 volts then. Again, I've got twice as much current, so I'd have twice as much voltage drop. Right now we have 12.25 amps flowing to our load, putting the load again on that circuit to check for what the voltage is. While the truck's running, even with that 12 amp load, we still have 12.73 volts that'd be available at the nose of the trailer. Comparing the amperage to the voltage, we look at the chart and this circuit does exceed the spec. I'm going to move over to the stop lamp circuit. Right now I have no current flow because the brakes are not applied. With the brake pedal pushed, we have the circuit energized, powering up our load, and we have an 11.46 amp load on this circuit. We look at our voltage, we have 12.60. Going back to our chart and comparing the amperage to the voltage, we're above the threshold, so this circuit does pass. I'm going to take my clip-on amp meter off the stop lamp circuit. I'm going to go to my ground because I want to see what my total load would be with both circuits energized. With both circuits energized, we had a total load of 23.52 amps. Our voltage at that point was 12.63. If you go up our chart, you can see that we're still in the pass range and this truck would be good. It's very important we keep that voltage above that line. If it drops below that, we're in danger of having the ABS or the analog braking system not work properly, which is obviously a safety issue. It can even be just a nuisance as far as tire life, that you can create flat spots and all kinds of other issues by the system not working properly simply because of too much voltage drop in the circuit.